On this episode of Shareable Science Beyond the Blog, let's explore how a 100-year-old tuberculosis vaccine might actually provide protection against COVID-19. Welcome to Shareable Science. Science you can share. Okay, the science behind this story is a little convoluted, but hang with me and we'll tie it all together. We're going to start with a vaccine that was created more than 100 years ago called BCG. It stands for Bacille Calmette Guerin, and French-speaking people around the world just shuddered at that pronunciation. The key is that BCG is a weakened but live bacteria, and that bacteria is a very close cousin of the bacteria that causes tuberculosis. So when you give someone this vaccine, it actually creates an immune response that protects them from developing tuberculosis down the road. More than 4 billion people have been given this vaccine over the last 100 years, and it has a really small number of side effects. It's important to note that this is not commonly used in the United States or Europe. It's much more standard of care in Asia and in Africa. Now, you might be wondering why I'm telling you about a bacterial vaccine when COVID-19 is a virus type of infection. Typically, we don't see those two interact with each other. The data suggests, and we've actually been seeing this for decades, that infants that are given the BCG vaccine have a lower infant mortality from lots of things. In other words, it seems to protect them not only from tuberculosis, but also from other types of infections, specifically respiratory infections. And that data has been looked at over the last several years and extends also to influenza and yellow fever. So if you've had a BCG vaccine as a child, it seems to protect you against other childhood respiratory illnesses. In order to explore the science behind this, let's take a quick dive. Actually, let's just skim the surface of a little bit of immunology data. We're going to talk about something called trained immunity. And specifically, we're going to talk about macrophages. They are a part of your immune system. They're this kind of shaped molecule. You can think of them as the first line defenders of your immune system, just like the police, emergency, EMS, and fire. Their job is at the site of an infection to identify the infection, engulf it, destroy it, and then call for reinforcements and backups if needed. And it's thought that the BCG vaccination actually preps and primes these macrophages to be at a higher state of alert to do their job better and more quickly respond to other infections, especially respiratory infections. We aren't sure how long this is actually effective. So if you were given this vaccine as a child, would it still be effective for you as a 40, 50, or 60-year-old? We know that it's effective within a few years after vaccination. We just don't know the longer time frame. So that really begs the question then, could the BCG vaccine offer some level of protection against COVID-19? So there's some early data that actually looks at the countries around the world that have an active BCG immunization policy and compares the rate of COVID-19 infection and death rates. And the early data suggests that these countries with BCG vaccinations may have a lower rate of infections and mortality. But there are all sort of biases around this. And this is a correlation. It's not a cause and effect piece. So in order to really see if this makes a difference, we have to start looking at clinical trials. And we're now seeing clinical trials begin all around the world asking this very question. And many of them are specifically offering the BCG vaccine to frontline medical workers. Now again, this is not a vaccine specifically for COVID-19. But through this trained immunity, it may provide some level of protection like it does for other respiratory viruses. So it could be a bridge until we actually have a COVID-19 vaccine. One important note, remember this vaccine is being used to protect infants against developing tuberculosis. If we suddenly discover that this does in fact provide protection against COVID-19, we have to make sure that we don't reallocate all those supplies for COVID-19 and leave infants unprotected against tuberculosis. So there's the background. There's the storyline. Like many of our other pieces, this bears additional watching and waiting as we see what the clinical trials tell us. If you find this is useful, please share this with those around you. Thank you for watching. I look forward to seeing you again, and take care.